I'm very honored to be joined by an amazing set of folks today. We have Mike from Intel, and Mike leads confidential computing engineering at Intel. We have Danielle, who leads product security at Nvidia, and my colleague Joanna, who looks after the confidential foundations platform at Google Cloud. And my name is Sam Lugani. I run product management for confidential computing at Google Cloud. We have a full roster today. We're going to talk about the encryption trifecta at rest, in use. We're going to dive deeper into confidential computing and, of course, talk about Nvidia and Intel's approach to confidential computing, and then close off with a deep dive and some more information about confidential space, which is our data collaboration offering. Now, we've come a very long way since 2019. 2019 was the year when Google and a few key partners got together to form the Confidential Computing Consortium. And in 2020, we became the first major cloud provider to offer confidential computing that was easy to use, a single click, it was just a single checkbox, no code changes required, lift and shift in the truest way possible. And the progress we've made since then is quite remarkable. Today, GCP provides best-in-class availability for confidential computing across the globe. So no matter what region you're in, no matter what organizational regional choice you make, you're going to have confidential computing available there. So we've really gone from what was a vision back then to an extensive portfolio of products, and today is a momentous day because we're going to define the next chapter of that journey within confidential computing. So to start things off, as we have conversations with customers, there's a few questions that keep coming up when we talk about data protection. And the first one is really that I want the highest level of protection for my encryption keys, especially for data which can't be anonymized or tokenized. And that's where encryption at rest comes in. And we have a full roster of options here. There's, within KMS, you can store your keys within the cloud, and you can manage them within the cloud console. CMEC, you can host your encryption keys within a hardware security module, HSM, and do all the crypto operations there. This is especially useful when you have compliance requirements, or you can have separation between where your encryption keys are stored and where your data is. That's EKM, or external key management. Once you've figured out the right encryption scheme, you got to do something useful with that data, because if that data is just sitting inside, encrypted somewhere, is not doing anything for you, then you're not making money off that data. So you've got to get that data into an instance, to a container, and do something useful with that data. But before you bring that data in, you want to make sure that those instances are hardened against attacks. And that's where shielded computing comes in. So shielded computing offers a set of security controls which hardens the VMs. And there's three aspects here. There's a VTPM, which is a virtual trusted platform module, which looks at your pre-boot sequence. There is integrity monitoring, and that looks at your runtime boot sequence. And the third element is secure boot, which looks at all these different signals. And if anything is out of order in the boot sequence, it will not let the instance boot up. And so this helps you protect against rootkits, bootkits, kernel-level malware as well. And the good news is it's turned on automatically by default on VMs and GKE nodes. So once you have encryption at rest figured out, what if you need more confidentiality and isolation around your data? And that's where confidential computing comes in, because confidential computing provides guarantees around isolation by providing these cryptographic guarantees, because the memory of the environments you're in is encrypted. And so we often talk about confidential computing in various ways. We're going to try and visualize this, so humor me a bit as we sort of move along. I'm going to wear my hat. I'm going to a bank in the 60s, and maybe that's how things used to be. I'm carrying my briefcase. It has this nice Google Cloud logo here, and some gold coins inside because we're in Vegas. And so as I walk in, this is closed. I have my encryption keys in my pocket. Data is encrypted at rest. And I'm going to a bank. I'm standing in one of the many teller lanes available, the day where we had teller services. And there's multiple people standing in these different swim lanes. So as I walk in, my data is protected. But as I walk to a teller and I open the box to transact on my data, data in use, I'm transacting on my data, I have to open the box and I have to transact on my data. So although I'm in my own teller lane, if someone besides me is so well inclined, they could potentially peek at what I'm doing and get some information out of it. Now comes my cloud umbrella. So now imagine you're in a bank world, and this sort of partakes for being a cloud world right now. And I do all the same exact transactions, but I do it within these isolated boundaries, wherein there is more protection and confidentiality around this data. So there's a couple of things that play here. There is more confidentiality because the environments themselves are encrypted. There's isolation. Workloads are isolated against other workloads on the same machine and the cloud provider. And then there is integrity as well. There's verifiability as well. And this comes in through attestation, because with attestation, you have guarantees that the environment and the data is secure and has not been altered in any way. Now, confidential computing is gaining popularity, awareness, and adoption for more than just being a data protection solution. It's changing ways that people do business in. So for example, AstraZeneca is using confidential computing to better healthcare outcomes for their patients. And there's another cool company, Monetago. They're using confidential computing to detect duplicate financing fraud. And their use case is pretty cool. When you go to a bank to take a loan, you have to put an asset as a collateral. And in a lot of regions, banks cannot communicate with each other because of regulation. So what if I go to a bank, I have one asset, and I get 5 different loans putting that exact same asset as collateral? Now, banks are not going to share their customer information with each other because that's PII, and that's problematic. That's fraud. And this is where confidential computing can help, where it can allow for this secure, private, multi-party collaboration to achieve these better business outcomes. And we'll talk a little more about that later. Now, one of the things we also want to do is make sure that confidential computing is easy to use, understand, and deploy. So as we increase the options within confidential computing with different hardware families, we want to make sure that anyone, a developer, someone within your company, can understand what are the right choices to make within this confidential computing ecosystem. And that's where our integration with Gemini comes in. So I want to introduce Gemini Google Cloud Assist for confidential computing. And here's a quick demo of what this looks like. So this is the Cloud Console. You want to start to create an instance. And as you create an instance, you're going to see this option which says explain this feature. And when you click on explain this feature, it'll give you contextual information on what confidential computing is going to be within your sort of project. Now, I want to move one step ahead, and I want to understand if someone within the project is already using confidential compute. So I can ask Gemini this question, which is, are there any instances already using confidential compute in this project? And it's going to look at all the different properties across instances and tell me that there are a few instances here, 3 in this case, that are already using confidential compute. Now, next step, I have my HPC requirements. I have my high performance computing requirements. So I want to understand what's the right machine type I should be using for those requirements which supports confidential compute. And I can ask this exact same question to Gemini. And Gemini is going to look at all the different options out there, what I've been using previously, and the best supported model for these new kind of instances which I want. And so in this case, it represents a C2D. It recommends a C2D machine family for this specific use case. And this is the first step we're taking in this direction. There's many more things we want to do with this integration, and you're going to see some more updates coming out soon. Now, we've also been working with Intel for a long time. And the effort has resulted in trying to make the whole confidential computing ecosystem better. So we collaborated with Intel last year to evaluate their TDX platform. And we found some areas of improvement together, and then collaborated on those areas to improve the overall ecosystem. And this is not just something which benefits a Google or an Intel. It's important that we create more trust within this ecosystem. And so when we work on such projects, it benefits everyone who's using confidential compute and all the providers of confidential compute as well. So this partnership has been very important for us. And I'm very excited to announce that the Intel TDX platform is going to be in public preview on the C3 machine family. It is already in public preview, and the general availability of that is going to be coming very soon. And a key feature of that is remote attestation, which is the ability to verify that the workload is running in a confidential environment. True to our heritage, there's no code changes required, again, in this specific case. But there's one more thing, and that thing is AMX, Advanced Matrix Extensions. This is Intel's effort to create CPU-based acceleration for AI and ML workloads. And I'm very excited to welcome Mike on stage to talk more about TDX and AMX and our partnership. Mike.
Thanks, Sam. I want to start by talking a little bit about confidential AI. Confidential AI is an industry movement responding to a growing need for improved security and control of AI models and data. And this is driven by several trends in the industry, such as the popularity of Gen AI and large language models shifting AI from the hands of the experts to the hands of general business population. And with broader use comes greater risk and therefore a need for more security. And another trend is multi-party computing. AI in general, many AI usages benefit from multiple data sets from multiple companies and multiple sources. And some of those data sets need to remain confidential, even as they're transported across company lines, even across geographic lines. And therefore, you need some level of security with those applications as well. Regulatory requirements are also a driver here. We see the leading player in this space is the EU with the Artificial Intelligence Act. That requires systems, AI systems, to be resilient against attacks that can alter or produce false answers or results. These types of things are driving a need for confidential AI, and that confidential AI solution is underpinned by confidential computing. And confidential computing was first introduced by Intel in 2018. And now it's supported by most leading silicon vendors. Confidential computing protects code and data while it executes, as Sam said. This is, perhaps where data is at its most vulnerable. It's in readable form, sitting in system memory or in the CPU itself. And this is where confidential computing comes into play. It protects that data with a trusted execution environment that hardens a boundary around the data and code as it executes. It reinforces that with encryption that is decrypted only inside the trusted execution environment and controlled by the user. And finally, it delivers that system integrity that Sam referred to that comes from cryptographic attestation that confirms that the trusted execution environment has high integrity before you load your data and code into it. Intel packages its confidential computing solution in Xeon processor, which also contains AI acceleration elements, in particular one called AMX or advanced matrix extensions. These technologies combine to make Xeon a leading inference platform in the AI community today. I want to talk a little bit more in depth about Intel TDX. Intel TDX, or Trust Domain Extension, is Intel's newest confidential computing technology. Google has just announced this week at Intel Vision and here at Google Next the availability of Intel TDX for public preview on C3 machines, as Sam just mentioned. Intel TDX is a hardware-based trusted execution environment that facilitates the deployment of trust domains. These trust domains are hardware-isolated virtual machines that are designed to protect sensitive data and applications as they execute within inside. Intel TDX is easy. Trust domains look to the application like a normal VM. So there's no need to change your code or alter or port your code over to TDX. You can simply use the applications as they exist. And most importantly, TDX is now available. Google has announced a public preview of it today, so this is consumable today in Google Cloud. Intel Xeon processors come with a new feature called AMX, which Sam mentioned earlier, and I'll go into just a little bit more detail here. AMX is a dedicated hardware block that helps accelerate deep learning workloads that rely on matrix math. Common deep learning use cases that benefit from AMX include recommender systems. So AMX can boost the responsiveness of systems such as a targeted movie, a book, or a targeted ad. Natural language processing. So AMX can accelerate text-based use cases such as clinical notes or service chatbots. Compute vision applications can benefit from AMX by reducing the time from image capture to insight. And Gen AI use cases can benefit from AMX by accelerating the training and inference of deep learning workloads in general. AI workloads can see up to a 10x performance boost from AMX and 7.7x energy savings with AMX. The chart on your right, my left, shows some benchmarks of common AI workloads running on AMX. And this is just showing the performance improvement of a CPU with AMX versus a CPU without. Intel makes it easy to get access to AMX. We have open source libraries that are easily accessible. We've also enabled AMX acceleration in some popular AI projects, including TensorFlow, PyTorch, and scikit-learn as examples. So AMX and TDX are both built into Intel Xeon processors, making the Xeon processor a strong foundation for a confidential AI solution. With AMX, you get the performance boost for your AI workloads. With TDX, you get the confidentiality that AI workloads are demanding more and more today. And all this is available today in public preview on Google Cloud.
Oops. Thank you.
Thanks.
Thanks so much, Mike. There's a new chapter of AI around the corner, and every session you've probably been to talks about AI now. Well, for CC, there's a new chapter for AI, and the inflection point is going to be coming up very soon, because what AI is doing is using your data to create these new growth levers, to create new business opportunities within your business. And when you use data to create these business opportunities, you want to make sure that that data is protected. So there's two aspects here. The first aspect is that the data used for training models needs to be secure, protected, and private. And we have to ensure that that data is protected from unauthorized access, from any kind of manipulation or poisoning. And that data set is very huge, it's gigantic. There could be sensitive data, there is healthcare transactions within that data, there is financial data that could be part of it, and you want to ensure that this data gets protected. And the second aspect is the models, the trained models and the weights themselves, which represent significant intellectual property, and they need to be protected as well. And because of these risks, many organizations are hesitant to adopt AI. So this great AI momentum we're seeing is going to be intertwined with this need for confidentiality, with this need for isolation, and with this need for verifiability. And that's why we're talking about confidential computing here, because the destinies of confidential computing and AI are going to be intertwined, and confidential computing can support organizations in their AI journey to make sure that that data stays confidential, is isolated, and there's verifiability built around that data. And that's why our journey of confidential computing doesn't really stop at specific services being enabled for confidential compute. We're on a mission to achieve confidential everything, a future where all data services can remain protected in use. And this includes extending confidential computing to GPUs, which are a critical resource for AI and machine learning. So today I want to announce that confidential compute is coming to A3 VMs with the Nvidia H100s, and it's going to be in private preview later this year. And this will enable customers to better protect the confidentiality of their data, their training data, as well as the models associated with some of that data. This is an incredible moment for us, and it's something we've been collaborating with Daniel, Nvidia, and their team for a very long time. So I'm delighted to welcome Daniel on stage to talk more about the H100 and the confidential computing.
Thank you, Sam, for that introduction. And yeah, no, it's probably not clear. You know, we've been working on confidential computing for about 4 years now with Google. I still remember the meeting. It was like January 2022, or 2020 rather, in Seattle. And I was having just a security meeting. So I see some security guys here in the audience. Just, you know, how do we secure the platform, make it better, more effective? And had this incidental run-in with Nellie Porter and the confidential computing team, who were staring at a very similar problem. I'd spent maybe 4 or 5 months looking at privacy-preserving technology and other techniques to really unlock workloads that, for various reasons, partners or others, were really locked in because of regulatory or IP risk. We're very uncomfortable moving it to a cloud space. And even at the time, Nvidia was a little hesitant about, you know, pursuing this confidential compute path. We're like, hey, where our customers going to value this? Would our partners like Google be interested in adapting this technology? And we sat down, and just over the course of 4 hours, over sort of a casual lunch and a dinner later that evening, both came away very energized, like, yes, this is the right path. Fast forward 4 years, it feels almost prophetic to be in this moment and have these sorts of solutions available, given the dynamics we see in market. And worth talking a little bit about that. There were really 3 core sort of trends we were staring at. One, of course, the just exponential growth in data and data volumes. 2, backing into that, the sort of rocket-like expansion of AI-enabled use cases, especially generative AI use cases, that make accessing the value of your data easier and more effective than ever before. And of course, just the intense demand for capacity and density at compute scales. Now, of course, when those data volumes drive up, so do your costs, right? So there's this strong tension between, hey, how do I manage costs but still get the privacy guarantees I need? And of course, with those demands came real concerns, right? You know, your most valuable data tends to be your most sensitive data as well, right? So the convergence of those 3 has really created a moment. You can see up here on the right sort of that AI inference workload where all 3 of those macro trends are kind of converging. And we're seeing today tremendous demand and growth for those inference-related workloads, sort of in that 20 to 300 billion parameter range, but that accounts for first-party models, third-party models, open source models, Llama, Bard, and related, where a lot of global enterprise growth is driving to, especially for those that are custom engineered, you know, fine-tuned, to be task-specific, to really enable growth for those organizations. So it really is a great moment. So the question is, how are we solving for this? And Google has been a great partner. They just launched the private preview announcement for A3. So let's double click a little bit and see what we get in that A3 deployment. And Michael said a lovely setup for me on the confidential enclave side, because it starts with a full node VM confidential enclave attached to 8 H100 GPUs in the system. That's a tremendous amount of graphics horsepower. You saw on that previous, and we can go back here, this box, that's sort of the sweet spot of the deployment that we're targeting here. That range allows for maximum utilization of those H100 GPUs. The CPU workloads are protected under that confidential enclave. You get to your application running in the enclave, everything protected at the application level, but also your AI models and data sets, the data that transits to the GPU is also protected because every GPU in that system is running in CC-enabled mode. All transit data between the CPU and GPU is likewise encrypted, hence protected PCIe. And we really lean into those attestation principles to have confidence that you're running on the platform you intended to, running the code you intended to really have trust in the environment and the data that you're running there. We are running with a relaxed NVLink policy. There is a high-speed GPU to GPU network communication fabric there. So maximizing that utility, really driving at those core use cases by enabling that policy that the user can opt into. And we see those workloads, Llama 2 and others, sort of in that sweet spot of that box, running at near 100% performance scaled across CC and non-CC. So you're not really compromising that much and still getting the advantage and cost performance of a full GPU deployment, which you may already be running now. So where did we land, right? You know, we had 3 core concerns, privacy and security and scale cost, right? So we've eliminated the security and hypervisor concerns using the CC enclaves, both CPU and GPU, to protect your data in use. We've addressed the core physical attack scenarios against the PCIe bus between CPU and GPU to have a total solution, and we've managed the cost downs using and accessing the full scope of AI workloads, frameworks, SDKs, libraries to enable your workload to run at maximum efficiency, including our Nickel SDK libraries, which enable that multi-GPU optimization workloads in that space. A3 is a great solution. We're super excited to deliver this with Google today. I encourage you to reach out to Joanna and team on the private preview side to really engage on that if you feel like this workload is where you need to be, especially if you have those core data sensitivities. I will note too that when you migrate from CC to non-CC, there are no, using the NVIDIA frameworks, there are no code level application changes you generally need to make. If it runs non-CC, it will run in CC as well. There are, of course, the attestation setups that need to happen at the VM level. I know Joanna's going to talk a little deep dive about how they're solving for making the VM access and deployments easier for you as well. So on both sides, Google and NVIDIA are trying to make this as easy as possible to shift to that confidential space and really enable those core target key workloads that are demanding at this time. That's really all I have to say. I'm going to hand it off to Joanna, who's going to do a deep dive on some of the solutioning Google team is doing to make the A3 fantastic for all of you.
Yeah, so you just heard from Mike from Intel about Intel TDX and Intel AMX. And now you heard from Daniel about the Nvidia H100 Tensor Core GPUs. And now, what has Google done with these amazing hardware technologies and innovations? Well, we've added it to our flagship confidential computing product called Confidential VMs. So confidential VMs are a compute engine virtual machine. And these VMs provide hardware-based memory encryption to ensure that your data and your applications cannot be read or modified while in use by any unauthorized users. What we've done here as well is to provide that cryptographic isolation. So we know when you put things in this cloud, you get virtualization. Each of the VMs are distinct, but we've added a cryptographic layer with this specialized hardware. And Google has made these VMs very, very easy to use, kind of that one-click enablement that the previous speakers has touched upon. And it makes sure that even if the host OS or the hypervisor is compromised, that you have those protections still in place. And we support a lot of different guest OS images, and we also are available in nearly all GCP regions and zones. And so, as Daniel mentioned, we believe that if it can run on a regular compute engine VM, it should be able to run on a confidential VM. And on top of it all, these VMs are very scalable and very performant. And so, kind of Sam mentioned, we offer a general purpose N2D type, and we also offer a compute optimized C2D VM type. All right, peeling back the onion. So confidential computing at Google Cloud kind of comes in three, what you call kind of flavors or types. It's kind of confidential computing type is kind of what you type in the command line. So the first one we were introduced to our confidential VMs was that AMD SEV. And what that stands for is AMD Secure Encrypted Virtualization. And what you get with that one is you get that code and data confidentiality that Sam has already mentioned. So what happens here is the hardware is generating a key per VM. And this helps isolate each of the VMs from each other and also the hypervisor. And then in the middle column, we have AMD SEV SMP, and that actually builds on top of AMD SEV. And so AMD SEV SMP stands for Secure Encrypted Virtualization, same thing as the left. And then you've added Secure Nested Paging. And so that one gets you that same code and data confidentiality. But on top of that, you also get memory integrity. And you also get remote attestation that Sam had mentioned before, that verifiability. And then what happens here is they've switched the model into making it so the threat model is you're kind of assuming kind of maybe a malicious hypervisor in the middle column. So now you're getting additional protections against attacks like data remapping or memory remapping or data replay. And so this one we have in preview, public preview today on our N2D VM families. Again, that really easy to use, just use an extra -- confidential computing type SMP. Moving to our amazing TDX that Mike has covered today is Intel Trust Domain Extensions. Okay, so this one we also are excited to announce our public preview, and with GA coming soon. And these give you that data and code confidentiality and memory integrity. So you can see how strong this technology is. And what it does is, as Mike mentioned, it puts each of the VMs into its own trust domain. So again, that cryptographic isolation between those VMs and from the hypervisor itself. Okay. So here are 3 quotes from our customers. So on the left, you have Thales, and they really use their confidential computing to protect and safeguard the integrity of their data and their customers' data, so really that privacy use case. In the middle, we have amazing Arjuna. They've added confidential computing to their Sea-Glass product, and you can see that they also mentioned they are very excited to use confidential computing for multiple AI use cases. Lastly, we have Edgeless, who've added confidential computing to their 2 products, Constellation and Contrast, and they're really excited to see this hardware diversification that Google Cloud is now offering. We've got multiple vendors, multiple confidential computing technologies that we're excited to release and make available to everybody in the public. All right, moving on to kind of the main focus of the talk, which is confidential AI and ML acceleration. So, you've already heard from the other guest speakers here about, Intel AMX, Nvidia GPUs, but what's the problem we're trying to solve here, right? I've come up with 4 areas that you may want to consider when you think about how would I even use this product. All right, number 1 is, we've heard from customers saying, well, how do I protect my training data and my data labels? Though my data labels is what's really proprietary to my company. So that's really that data protection realm. Number 2, how do I ensure that my model weights are protected and not tampered with? So sometimes the model itself is what needs to be protected because you want to share and have others use the model without losing control. Number 3, I don't want to break any privacy laws or compliance issues, run into them when I'm doing my AI workloads. And so this is really that compliance, auditing, data regulations scenario. So data regulations are constantly changing, and making sure that you have the right security in place is paramount. Lastly, it's really that special use case that confidential computing can unlock, which is really sharing data in a secure manner without perhaps revealing the underlying individual data sets, right? So maybe they want to share their data and their models on a data exchange without losing that control. So these are some kind of the areas you want to be thinking about when you hear about Intel AMX, for example. So Intel AMX, we're really excited to have them enabled by default on all C3 machine series VMs. And because confidential VMs are also offered on this general purpose C3 machine series, that means you get Intel TDX and Intel AMX on by default, already all in one with no extra things besides another extra command line -- confidential compute type. So Intel AMX stands for Advanced Matrix Extensions. It's the built-in accelerator. Intel had already come up with previous acceleration on the CPU, and now this is their latest generation. And it ensures you have very good performance for deep learning training and inference workloads. So, I was reading into the history of Intel AMX, and it was actually AVX prior, and that one was very well adopted by inference workloads. But then they developed AMX to really expand into the training workloads. So really, that's where the highlight is. So you get that great performance, kind of that middle column. And lastly, easy to use, right? So the AMX instructions are integrated with the latest PyTorch and TensorFlow frameworks. Okay, so we talked about the extensions, but what are some deeper examples of how do I use this, right? So as Mike mentioned, the first one is personalized recommendation engines. Let's say you want to build a recommendation engine, but that requires the use of real-time user behavior data, which is really sensitive and needs to be heavily guarded. Well, you can use Intel AMX with Intel TDX to protect that data at the same time while remaining performant. Middle column, natural language processing, the chatbot. So let's say you want to create a chatbot, but you want to make sure that anybody typing their sensitive data into the chatbot is protected from not only the person creating the chatbot, but perhaps maybe the one that's hosting the chatbot, right? So that'd be Google Cloud. So I want to call out that I highly recommend visiting the Intel booth down in the expo hall. They have this exact thing on demo right now. They have a TDX demo. They also have an AMX demo. Their TDX demo is a chatbot, so you definitely want to go check that out. And lastly, we have retail e-commerce applications. Pretty simple, easy here. You want to make sure you have the best customer experience. You want to reduce those transaction times. You want to make sure forecasting is on point. And what does that require? Perhaps massive amounts of sensitive data that needs to be kept protected and shielded, with something like the umbrella. All right. And next, I just want to touch upon the Nvidia GPUs that you've already heard lots about. So it's the Nvidia H100 Tensor Core GPUs. And these are very high-performing GPUs. So we actually already offer these GPUs in our general available A3 VM series. And now we're working on the confidential computing mode of that H100 GPUs. So similar to how our confidential CPUs work, it makes sure that only authorized users can place data and code into that environment. And that's kind of the reverse, where no unauthorized access can read or modify what's in your CPU and TPU that's been protected by this TEE. Okay? So yeah, no code changes to enable this. This is really that easy to use. And lastly, it'll be on our A3 machine series, and we currently have it in ready for you to sign up on the interest form. So you can scan that QR code and fill out what you need to be using confidential GPUs for. And we've constantly thrown around this word protected PCIe, but what is that? So PCIe first means peripheral component interconnect express. And so that is a connection type that allows for high-speed data transfers between two electronic components. So in this case, we're talking about the CPU to the GPU. And for this one, on the chart on the left, you can see a regular VM, has its CPU, and a regular GPU. Those transfers between the GPU and the CPU are typically unencrypted, right? Get that speed, good to go. And so in order to make this a confidential computing environment, we've now encrypted the transfers between the two electronic components. Okay, so not only does that get you protections during any sort of PCIe attack, but also there's other protections that they've put in place onto the confidential H100 GPUs. So they've also added kind of firewall protection, they've disabled sideband channels, and they've also disabled performance counters, so you do have to use their special tools to do performance monitoring and testing. And lastly, you can kind of see on the right-hand side how, if you created a TE around the CPU and the GPU. And this is going to be my last slide, but what are we using this for? Kind of simply, there's a lot of places where you can add data protection, and you had a lot of sensitive workloads that you need to use for AI work to take your data to the next level. Right, so maybe you have AI intellectual property. The stuff that you're training your models on is your most valuable data, and so doing that in a safe, secure manner is necessary. Maybe you want to do a lot of training and inference, and that's going to require a lot of security as well, but you want to maintain that performance. And lastly, it's that secure multi-party collaboration that we want to bring to the table that actually Sam is going to talk about next.
Thank you so much, Joanna. So we went through a bunch of topics. We started off with encryption at rest, and we hardened our VMs and instances, and then we dived deeper into confidential computing and confidential accelerators. Now, the next step in this journey is that what if you want to start collaborating on data with other parties whom you may not trust as much? Can you accomplish that with confidential computing? And of course, since we have this slide here, the answer is going to be yes, because that's exactly what confidential space is all about. Confidential space creates a TE, or a trusted execution environment, and accomplishes three things. The first is that there's confidentiality because the environment is encrypted. The second is that the operator or the workload owner is outside the trust boundary. And the third aspect is integrity, which comes in through attestation. So lots of keywords, but what you're trying to accomplish here is to enable data sharing and data collaboration without having to trust other parties blindly. So let's take an example. Let's say there's a hospital, and they want to create a training model based on radiology images, and they want that model to look at those radiology images and ascertain if there's any diseases reflected in those radiology images. So of course, they probably have a repository of what they've gathered over the years, and they can create an ML model on that, and that might work fine. But what could be even better is if multiple hospitals come together and participate in training that model. It's better for them, it's better for humanity in general. But of course, they want to maintain ownership of that data. They want to make sure that that data isn't exfiltrated. And they can accomplish that by using something like confidential space. So let's take a peek at a demo here, but I'll give some context before we get into this demo. So you may have heard of RAG, or retrieval augmented generation. Essentially, it's really a technique that enhances the accuracy of LLMs by making sure that you're getting data from trusted repositories, and so it reduces the hallucinations that sometimes we encounter with LLMs. So in this specific case, there's an organization, and they want to create a chatbot that Joanna was talking about earlier. And with that chatbot, they're using an off-the-shelf LLM, and they want to make sure that that LLM itself is in a trusted execution environment. Because once it's there, then their data and the prompts they're doing to that LLM are protected, as well as they have protections from the cloud provider. And then they also want to make sure that their own private data, which is being hosted in the vector DB, is also protected against its own insiders and the cloud provider. So that's where the second TE is. So if everything functions brilliantly well, there's a user, they query the LLM is able to get augmented data from the vector DB and associate that data with the user query to give a better outcome for the user and reduce hallucinations. And we're going to see how this works in practice. So here we have the first TE configured. So the LLM itself is in a TE. It has confidential space on it. It's using Intel TDX with all the AMX acceleration it's getting as well. And secure boot is turned on. The second TE, which is for the vector DB, isn't configured correctly. So in this case, if we query saying that what is Intel TDX, we're not going to get an answer because the second TE is not configured correctly. Now, we could maybe switch to a regular LLM, which is right in the top corner. Now, when we do that, you're not getting the augmented data from that trusted source. So if we ask that same question, what is Intel TDX, we're going to get an answer from the LLM, but that answer is it's Intel Taxonomy Data Center Manager, and it's not contextual to me. That's the beauty of RAG, because it gets you contextual data. Now, we'll do the same thing now, but in this specific case, we'll try and make sure that the TE gets configured correctly. So now we're going to configure the TE correctly, and as you can see, it's all green. Green is always good. That's what I've learned in life. Everything green is good. So this TE is configured correctly, and now we're going to ask the same question around what is Intel TDX, and let's see what the LLM now says, because now it's going to get that benefit of the retrieval augmented generation that we showed earlier. And in this case, it gives you that contextual answer. So this is a very easy way for organizations to actually look at generic LLM models out there, do more stuff with it, and customize it to their own needs, but doing it in a way that's confidential, doing it in a way where your data stays protected. Great. So we talked about a bunch of things. We talked about the foundational elements, which is confidential VMs and GKE. We introduced that Intel TDX is now in public preview, so you can start using it. We introduced accelerators today, AMX, and of course, the H100, confidential computing on the H100. We didn't touch upon the analytics part, but we have confidential data flow and confidential data proc. So if you have streaming analytics needs, you can enable confidential computing for data flow. If there's Hadoop and managed Spark, you can use confidential data proc as well. And then we talked about our data collaboration solution, which is confidential space. So next steps, try it out. Confidential VMs, it's as simple as a checkbox. So when you go to Pantheon, you'll start to create an instance. You'll see that confidential computing checkbox, and you can try it out within your own organization, within your own project. You can sign up for the confidential GPU preview that we're going to offer later this year. So scan this barcode, and it's on our website as well. And then the demo we had earlier around Intel TDX, there's a lot of nice code labs for confidential space that we have. And so you can it offers step-by-step instructions for you to create this secure collaboration environment. So try it out. It's going to sort of walk you through that entire process. And there's some lovely sessions. 2 of the sessions happened yesterday, but there's more to come later today. 2 specific mentions. There's a cloud key management system. We talked about encryption earlier. It's going to deep dive into that, and there's a few new announcements there as well. And there's a very nicely named session, Beyond the Cookie Crumbs. It talks about third-party cookie deprecation and confidential space in general. So if you liked what you saw here in terms of secure collaboration, you will see much more of that in that session. And again, we tried to sort of come to you with more demos. Let us know what you liked or not about this session. So your feedback is really important, because that way next year we can come to you with a lot more content. We're out of time, but we're going to hang here. So if you have questions, please come by. Feedback is always welcome. So thank you very much for making time and attending this session.